Thank you, Yagen. My name is David, and I'm going to talk about simulation. So simulation plays a critical role in providing data that is difficult to source and/or hard to label. However, 3D scenes are notoriously slow to produce. Take, for example, the simulated scene playing behind me. A complex intersection from Market Street in San Francisco. It would take 2 weeks for artists to complete. And for us, that is painfully slow. However, I'm going to talk about using Yagen's automated ground truth labels along with some brand new tooling that allows us to procedurally generate this scene and many like it in just 5 minutes. That's an amazing 1,000 times faster than before. So let's dive in to how a scene like this is created. We start by piping the automated ground truth labels into our simulated world creator tooling inside the software Houdini. Starting with road boundary labels, we can generate a solid road mesh and retopologize it with the lane graph labels. This helps inform important road details like crossroad slope and detailed material blending. Next, we can use the line data and sweep geometry across its surface and project it to the road, creating lane paint decals. Next, using median edges, we can spawn island geometry and populate it with randomized foliage. This drastically changes the visibility of the scene. Now, the outside world can be generated through a series of randomized heuristics. Modular building generators create visual obstructions, while randomly placed objects like hydrants can change the color of the curbs, while trees can drop leaves below it, obscuring lines or edges. Next, we can bring in map data to inform positions of things like traffic lights or stop signs. We can trace along its normal to collect important information like number of lanes and even get accurate street names on the signs themselves. Next, using lane graph, we can determine lane connectivity and spawn directional road markings on the road and their accompanying road signs. And finally, with lane graph itself, we can determine lane adjacency and other useful metrics to spawn randomized traffic permutations inside our simulator. And again, this is all automatic, no artists in the loop, and happens within minutes. And now this sets us up to do some pretty cool things. Since everything is based on data and heuristics, we can start to fuzz parameters to create visual variations of the single ground truth. It can be as subtle as object placement and random material swapping to more drastic changes like entirely new biomes or locations of environment, like urban, suburban, or rural. This allows us to create infinite targeted permutations for specific ground truths that we need more ground truth for. And all this happens within a click of a button. And we can even take this one step further by altering our ground truth itself. Say John wants his network to pay more attention to directional road markings to better detect an upcoming captive left turn lane. We can start to procedurally alter our lane graph inside the simulator to help create entirely new flows through this intersection to help focus the network's attention to the road markings to create more accurate predictions. And this is a great example of how this tooling allows us to create new data that could never be collected from the real world. And the true power of this tool is in its architecture and how we can run all tasks in parallel to infinitely scale. So you saw the tile creator tool in action, converting the ground truth labels into their counterparts. Next, we can use our tile extractor tool to divide this data into geohash tiles about 150 meters square in size. We then save out that data into separate geometry and instance files. This gives us a clean source of data that's easy to load and allows us to be rendering engine agnostic for the future. Then, using a tile loader tool, we can summon any number of those cache tiles using a geohash ID. Currently, we're doing about these 5x5 tiles or 3x3, usually centered around fleet hotspots or interesting lane graph locations. And the tile loader also converts these tile sets into U assets for consumption by the Unreal Engine and gives you a finished product from what you saw in the first slide. And this really sets us up for size and scale. And as you can see on the map behind us, we can easily generate most of San Francisco city streets. And this didn't take years or even months of work, but rather 2 weeks by one person. And we can continue to manage and grow all this data using our PDG network inside of the tooling. This allows us to throw compute at it and regenerate all these tile sets overnight. This ensures all environments are of consistent quality and features, which is super important for training, since new ontologies and signals are constantly released. And now, to come full circle, because we generated all these tile sets from ground truth data, they contain all the weird intricacies from the real world, and we can combine that with the procedural, visual, and traffic variety to create limitless, targeted data for the network to learn from. And that concludes the sim section. I'll pass it to Kate to talk about how we can use all this data to improve autopilot. Thank you.